In this video, we're going to talk about rational functions. There's a lot of concepts and vocabulary in this particular section, so I'm going to be highlighting that in particular. So the first thing that we need to understand is the word rational. The word rational has the word ratio inside. So when we think of a ratio, we're going to think of anything that's a fraction. So this here is a ratio of two numbers. So that essentially is a fraction. So if I have some number on the top and some number on the bottom, so that gives me a fraction. So when we're looking here, we have a fraction. What you need to recognize is my numerator is one number and my denominator is another number. They're two separate numbers. Remember our order of operations? We would have to simplify this to one number, simplify this to the other number before we can divide. So I can't just hash out things that look the same. So in order to do this particular problem, in order for us to actually simplify it and to graph it, what we have to do is our favorite thing, and we will call that factor. Okay? So pretty much in Algebra 2, when in doubt, factor it out. So when I look at the numerator, that's linear. That's okay. But when I look at the denominator, this is a quadratic. So I need to factor this quadratic right here. So if we remember, we'll do a quick review on factoring for those people who are still struggling a little bit. So what I'm going to do is I multiply my first and my last, so I get 3x squared, and I put my middle number in the bottom. So I want my factors of 3x squared that add to negative 4x, which would give me negative 1x, negative 3x. So those are the factors that I want, those are the products that I want to use to replace that middle number. So that means then that I would have x squared minus 1x minus 3x plus 3, because remember I'm just replacing that negative 4x. Factor by grouping, I can divide an x out of the first group, which leaves me with x minus 1 when I divide. And here, because this term is negative, I'm going to divide out a negative. Common factor is negative 3. And that's going to give me x minus 1 when I divide. So my factors are x minus 3, x minus 1. So I'm going to rewrite my rational function to be y. My numerator has not changed, but my denominator is now factored. So I have x minus 3, x minus 1. So why did I do this? I did this because I have to make sure there are no restrictions in my denominator. So remember, an important thing to remember, let's put this down here. So remember, you can't divide by 0, okay? You can't divide by 0. So any value of x in the denominator that would make my denominator a 0 would be forbidden. So that would be a restriction. So I'm going to ask myself, do I have any values of x that make the denominator equal 0? That would be called a restriction. That is a vocabulary word, a restriction. So let's look at our denominator. So I know when x, I'll write this here. So when x equals 3, or when x equals 1, that denominator is going to become a 0. So where x is 3 and where x is 1 are values that x cannot be. So my restrictions would be, let's write this like this. So this would be up here. I'm going to write my restrictions. I'm going to say x cannot be 3 and x cannot be 1. Those are my restrictions. I'm going to make a little arrow like this. Those are my restrictions. So notice I just did an x and a y axis here because I'm going to sketch. And the first thing I need to sketch is where my restrictions are. So where x is 1 would be about here. And where x is 3 would be here. So remember, x is 1 everywhere along here. That's a vertical line. And I'm doing it dashed because this is not a part of my function. That's just a restriction. And then I also have a vertical line here. And those vertical lines, or those absolute restrictions like that, are called asymptotes. So I'm also going to label this asymptote. So I'll spell it like this. So I have an asymptote there, and I have an asymptote there. And my function cannot cross or touch the asymptote. So if we were going to go ahead and graph this, it's just for the sake of ease, we're going to go ahead and put it into our calculator. And when we put it into our calculator, that is what this function looks like. So I'm going to show you what it looks like in y equals. I put it in that way, but you could also put it in, if you don't have the fraction function, you would do parentheses, x plus 3, close parentheses, divided by parentheses, x squared minus 4x plus 3. That's the other way that you could put that in if you do not have the ability to put it in as a fraction. So you can see it traced right over it. So I can see here I have a restriction here and here. If I were to graph this or sketch it, notice how my function looks like it runs along, I'll show you a different color, use green, runs along my x-axis, and then it starts to come up, and it gets really close to that asymptote. On this side, it runs down the asymptote, like that, and then here I have a part of the function that actually kind of comes in between. There is no vertical, it's all very stiff. I mean, almost straight. It's just very close. So notice I have arrows on everything. This is one function. This is not 3 functions. This is one function. So I know that I have, if I were to be asked for asymptotes, I would say that I have asymptotes at x equals 3 or x equals 1. And specifically, those are vertical. So that's key. That's a vertical. So that's a vertical asymptote. Now, when I'm looking at this function, there is nothing that I can simplify. So that would mean that that's all that I can do with that particular function as far as graphing it goes. We will talk about horizontal asymptotes in another video, and we'll also talk about how to simplify rational functions in another video.